see the working rule for finding oblique asymptotes here, and that is finding all the asymptotes of the given curves which is not parallel to any coordinate axes here. So first step what we have, consider the equation what is given there, the curve in the terms of nth degree representing the given curve that f of x comma y equal to 0, and that equation I must be converted to the hn plus hn minus 1 plus hn minus 2 plus dot 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 equal to 0. What is hn here? That is hn is something called homogeneous expression of x and y in nth degree. For example, if I have x cube y plus 4x square equal to 0, it's my curve or equation is given here. And my n is what? N equal to, look at it, n is the highest degree in this equation of the x and y. X and y together I am considering here. So x degree is 3 and y degree is 1. So together it will be 4. That is h4 here. You get it? So h4 I can write as x cube into y is my h4. That's an example for that. And what I am going to do, once you got represented the given equation hn minus 1, hn minus 2 plus that equal to 0, that means in the terms of this groupism. Okay, we should take it as a groups. X cube into y as h4 plus x square, that is h2. h3 is not there in this equation. Let's get that. So this equation I can represent in what way? h4 plus h2 equal to 0. That means you get that. So this is that becomes now what we need to do, 1 y equal to 3, we place it in step number 1, we get pi n of 3 plus pi n minus 1 to 3 plus pi n minus 2 of m equal to my m plus data equal to 0. So what is this pi n of m? See, for example, this equation I am considering. I am replacing wherever x comes 1 and y comes as y replacing as m. This becomes x is 1 cube into m plus 4 into 1. This equal to 0. This becomes m plus 4. You get m plus 4. So you will be getting equation in the terms of m. So that's why I am setting that pi n of m. You get that? So now solve this pi n of m equal to 0. We know that if we solve f of x equal to 0, I am getting the solution in terms of x variable, right? So here also pi n of m is a function for me. When I solve it for equal to 0, I will be getting the slopes of given asymptotes as m1, m2, m3. These are the roots for the given pi n of m here. If my roots m1, m2 are distinct, I will go to step number 4 by using the formula c equal to minus of pi n minus 1 of m divided by pi n dash of m. You get that? So pi n minus 1 means previous second term. Pi n is this pi n. For example, look at it. This is pi n. I can consider this as a pi 3. Get it? Pi 3 of m. This 4 is pi 2. You get that? So now what will be there? Minus of pi 2 divided by pi 3 will be existing if I have a cubic equation. So this is the formula what I have to find the c value. Once I find the c values, replace the c values for the required asymptotes. The required asymptotes are y equal to mx plus c1. So where for m1, for m2 I am getting new asymptome, and similarly for m3 also I will be existing the asymptotes here. So these are the final equations. What are we getting here? The lines here. See, look at asymptotes are the same as lines here. Okay. So y equal to mx plus cc. Look at here. Y equal to mx plus c is line, straight line equation, right? So y equal to mx plus c will be an asymptome for me. If not, if my roots are not distinct, that means my roots are same. M is repeated twice. That example m equal to 1 and again m equal to 1 I got it. Then you replace this c square by 2 pi n double dash of m plus c pi n minus 1 dash of m plus dot equal to 0 as your condition to get the asymptotes here. The condition is here, the number of asymptotes will not be exceeding more than the degree of the equation. For example, this small equation I am taking, look at it. What is the degree here? 4, right? h4, that is 3 into plus 1, 3 plus 1, 4. So the now asymptotes for this given x cube into y dash plus 4x square equal to 0, it will be more. It will be 4, not more than 4 will be there. You get that? It can be 2 or 3, but not more than the degree 4. So now when finding all the asymptotes of given curve, y cube minus x square y plus 2y square plus 4y plus 1 equal to 0. The given curve I am taking here, y cube minus x square y plus 2y square plus 4y plus 1 equal to 0. Consider this Let me consider it as equation number 1. So now I am going to find that I am going to represent this equation in the h term. n plus hn minus 1 plus hn minus 2 plus dot 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 equal to 0. We know that. So now I am going to equate to step number 1. So now what will be happening for me here? So now what will be existing? First check hn, that means highest term of degree n in this equation. So 3 is the highest term. So that means I need to consider 3 terms separately. I need to consider the degree 3 separately. 1 of 3 y3, is it clear? Minus, look at x square and y. X square into y, that means the y degree is 1. So since it's multiplying x and y 2 plus 1 will be existing as 3, that becomes x square, y also will be my h3. Get that? So h3 will be y cube minus x square y. You know that h3 is the homogeneous expression of x and y of degree 3. You get that? Degree of this x and y will be 3. X square into y, that means 2 plus 1 will be 3 degree form. Degree will be 3. So now h3. Now h2. Next previous term will be next. hn is over, hn minus 1 I am finding. So h3 is over, h2 I am going to find. h2 will be the expression of x and y, homogeneous expression of x and y of degree 2 here. So now degree 2 I need to consider. Now look at it. Only 2y square I have here. Degree is 2 for y. Degree of y equal to 2 here. So now h1, next one, 4y. Is it clear? Because degree is 1, so h1 equal to 1. h1 equal to 4y. Because degree equal to 1. Now h0, h0 equal to 1 because it's a constant I am considering. Now according to the step number 2, what I am going to do, h3 plus h2 plus h1 plus h0 equal to 0. So now h3 will be y3 minus x square y plus 2y square plus 4y plus 1 equal to 0. We get that. Now what is the next step for me? I need to get equal to 1. I need to replace x equal to 1 and y equal to m here in this equation 2. Let me consider this equation 2. Now x equal to 1 and y equal to m I am replacing. So what I will be getting? Y cube, right? M cube minus x square into y, that becomes 1 into m, that becomes m cube minus m plus 2y square, that becomes 2m square plus 4y, that becomes 4 into m plus 1 equal to 0. Is it clear? So these are the things what we got now. Now in this case I need to find what is our phi of n minus 1. I need to find phi n here, phi n minus 1 here. So phi n equation in terms of m I am going to compare with the step number 3 that says that phi n of m plus phi n minus 1 of m plus dot 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 equal to 0, right? So in this case phi n is what? N equal to 3. Degree is 3, that becomes phi 3 of m. What is the answer? Plus phi 2 of m plus next one phi 1 of m plus dot 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 equal to 0. What you got it? Is it clear? So now this becomes phi 3 of m. We need to find what is that here? M cube minus m. Okay. Phi 2 of m will be 2m square. You get that? Phi 1 of m will be 4m. So now after finding phi 3 of m, phi 2 of m and phi 1 of m, you got it the values from this previous step. So now what our intention is to find the m values. How to find m values? For that what I need to consider here. Step number 3 says for me, let phi n of m equal to 0. We need to solve this equation. So this becomes phi n of 3 means here I have n is highest degree is 3, right? So that becomes phi 3 of m equal to 0. That implies I need to solve the equation m pi 3 of m, that is m cube minus m equal to 0. That becomes m cube minus m equal to 0. Now I need to find the m values. Let me consider this m I take outside, this becomes m square minus 1 equal to 0. From here m equal to 0 and m square minus 1 equal to 0. So m equal to 0 and m square equal to 1. This becomes m equal to 0, m equal to plus or minus 1. Therefore, my m values will be 0, minus 1 and plus 1, which are not same. That means distinct. We found m values. Once we found m values, we are going for the c value. C value equal to, we know that c equal to minus of 5 n minus 1 of m divided by 5 of n divided by 5 n dash of m is equal to, this becomes minus of 5 2 of m divided by 5 3 dash of m. So we know that what is 5 2 of m, that becomes 2m square divided by minus, okay, minus 2m square divided by 5 3 of m is equal to m cube minus m. So 5 3 dash of m equal to differentiation of this 3m square minus 1. So this becomes 3m square minus 1. Now this is the c. Now for m1 equal to 0, I am finding c1. c1 equal to minus 2 of 0 divided by 3 of 0 minus 1, that becomes 0. That means my m1, right? Replacing m1 is 0. So for asymptome, therefore the asymptome y equal to m1x plus c1. So this becomes y equal to m1 is what? 0 into x plus c1 is 0. This becomes y equal to 0. This is one asymptome you found it. Now for m equal to 2, m equal, that is m2 equal to minus 1, m2 equal to minus 1. This becomes c2 equal to minus of 2 m2 square divided by 3 m2 square minus 1. So this becomes c2 equal to minus 2 into minus 1 whole square divided by 3 into minus 1 whole square minus 1. This becomes minus 2 into 1 divided by 3 minus 1. Finally I will be getting as minus 1. Minus 2 divided by 2 will be minus 1. So m2 equal to minus 1, c2 equal to minus 1. So asymptote y equal to m2 of x plus c2, right? So this becomes y equal to minus 1 into x plus minus c2 is minus 1, right? Minus 1. So this becomes y equal to minus x minus 1. So let me take it everything in a left hand side of this y, then it will be standard form for us. So when I take this side x, minus x will come plus x this side, plus y plus 1 equal to 0. That becomes x plus y plus 1 equal to 0. Now m3 equal to 1. So my c3 will be minus of 2 m3 square divided by 3 m3 square minus 1. So c3 equal to minus 2 into m3 is what? 1 square divided by 3 into 1 square minus 1. This becomes minus 2 divided by 2, again minus 1. So my asymptote y equal to m3x plus c3. So this becomes y equal to x, m3 equal to 1, right? So 1 into x minus 1. So I can write this as x. I can bring y this side, x minus y minus 1 equal to 0. So now we have found symptoms when m equal to m1 equal to 0 and c1 equal to 0. And second one, m1 equal to minus 1, c1 m2 equal to minus 1, c2 equal to minus 1, and m3 equal to 1, c3 equal to minus 1. All the asymptotes of the given curve is or 0 y equal to 0, x plus y plus 1 equal to 0, x minus y minus 1 equal to 0. So let us proceed for another problem here. That's given as find all the asymptotes of the curve 4x square into y minus x plus y into y minus 2 into x minus y equal to 4x plus 4y minus 7. So you consider this and start simplify this equation. Bring it to our standard forms called h3, h2, h1 like that. Okay. So now this becomes, when I multiply everything inside, 4x square y minus 4x cube. Okay, plus y into y square, or else you just come back, just to multiply these two first. What will be there? Y into x, xy minus 2 into square minus 2x plus 2y minus 4x. I'll bring inside right left hand side minus 4y plus 7 equal to 0. Now again further multiply that y also inside, so that becomes 4x square y minus 4x cube plus x y square minus y cube minus 2xy plus 2y square minus 4x minus 4y plus 7 equal to 0. Now you bring it in the standard form, that's called h3. To see highest degree, you see x cube is there, there is 3 degree here, y cube also 3 degree is 3, and here also x square into y, the complete term x square into y, the degree will be 3 only for me here also. So bring it that x3 terms first, that becomes 4x square y minus 4x cube plus x y square, that becomes x into y square, x into y square, right, square, that means 2 in plus 1, that becomes 3, so minus y cube. So anywhere this will be my one grouping term, that's h3 minus, next I will be getting minus 2xy plus 2y square because the degree is 2 here, minus 4x minus 4y plus 7 equal to 0. From here what I can consider, h3 will be 4x square y minus 4x cube plus xy square minus y cube. My h2 will be minus 2xy plus 2y square. My h1 will be minus 4x minus 4y. My h0 will be 7. Get that? Now when you keep any standard, we already kept it. h3 plus h2 plus h1 plus h0. What is my next step? I need to replace wherever x comes equal to 1 and y comes as m in the equation number 2 what I considered here. So now this equation becomes, look at it, I have here 4x square y minus 4x cube plus x y square minus y cube, right? Here in this case wherever x is there 1 I replacing and y equal to m, right? So that becomes 4m minus 4 into 1 x equal to 1, right, plus m square, next minus m cube minus 2 into x equal to 1 again here, y equal to m, that becomes minus 2m plus 2m square. Next one will be minus 4 plus 4m plus 7 equal to 0. You get that? So these are the things what you got it. So 4m minus 4 plus m square minus m cube minus 2m plus 2m square minus 4 plus 4m plus 7 equal to 0. So here I need to compare this with standard equation what I have, 5n of m plus 5n minus 1 of m plus dot 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 equal to 0. So this becomes, here when I compare it with my standard equation, my pi 3 of m will be equal to my, I will write in a degree proper, minus m cube plus m square plus 4m minus 4. Get that? So next pi 2 of m will be 2m square minus 2m, and pi 3 of m, so pi 1 of m will be minus 4m will be plus 4m minus 4. You get that? So now I need to find the m value. To find m value, what I need to do? Phi 3 of m equal to 0 I need to consider. You get that? What is phi 3 of m equal to 0 here? That becomes minus m cubed plus m square plus 4m minus 4 equal to 0. By using synthetic method, first find the m values here. You get that we have a cubic equation, right? Now what we are going to do, since we have cubic equation, let me replace it as m equal to 1, triangle method. You get it? Once I replace m equal to 1, what will be there? Minus 1 plus 1 plus 4 minus 4, that becomes 0. Look at it, LHS will be same, RHS, right? So minus 1 cube, yeah, we go minus 1 of cube plus 1 square plus 4 into 1 minus 4. This becomes minus 1 plus 1 plus 4 minus 4. This becomes 0. Therefore, m equal to 1 is one of the root of the given equation. We get that. Since pick method will be minus 1, 1, 4, minus 4 for the coefficients of the given equation and start with 0. We know that minus 1, again minus 1, 0, 0, 4 into 4, that becomes 0. So it's correct. Now my cubic equation converted into quadratic equation, that is what? Minus 1m square plus 0m plus 4 equal to 0. So now what will be there? Minus m square plus 4 equal to 0. Minus m square equal to minus 4. Minus minus will get cancelled. M square equal to 4. M equal to plus or minus 2. So what are the values? Three values I got it. M equal to 1. M equal to plus or minus 2. That means m equal to 1 and m equal to minus 2 and m equal to plus 2. Now using m values, now we are going to find the c value. Minus phi n minus 1 of m divided by phi n dash of m. Right? So this becomes minus phi 2 of m divided by phi 3 dash of m. Now we know that what is phi 3 of m. What is phi 3 of m? Already we know that minus m cube plus m square plus 4m minus 4, right? So this becomes phi 3 dash of m will be minus 3m square plus 2m plus 4. Yeah. Now get we substitute back for the c value. So c1 will be pi 2 minus of pi 2 is what? Pi 2 we know that 2m 1 square minus 2m 1 divided by pi 3 of dash of m, that becomes minus 3 m1 square plus 2m1 plus 4. Get it? So now c1 equal to, for m1 equal to 1, my c1 equal to minus of 2 into 1 square minus 2 into 1 divided by minus 3 into 1 square plus 2 into 1 plus 4. So this becomes 2 minus 2, 0. 0 divided by anything will be 0. We know that this becomes minus 3 plus 2 plus 4. Since numerator is 0, my c1 will be 0. The asymptote for this y equal to m1x plus c1, right? So this becomes y equal to m1 is 1, 1 into x, x plus 0. So this implies y equal to x is my first asymptote what you got it here. Now for m2 equal to minus 2 I am considering, so c2 will be minus of m2, right? So that becomes pi n minus 2, right? Pi 2 of this. So minus of 2m square minus 2m divided by pi 3 of dash, that becomes here we have minus 3m square plus 2m plus 4. So my c2 will be, is it clear? So I am replacing that m as m2 here, that's it. So c2 will be minus of 2 into minus 2 whole square minus 2 into 2 minus 2 divided by minus 3 into 2 minus 2 whole square plus 2 into minus 2 plus 4. On simplification, C2 will be minus of minus, look at it, what will be there, 8 minus of minus plus will be 4 divided by minus 3 into 4, that becomes minus 12 minus 4 plus 4. Get that? So this becomes minus of 1. 12 divided by plus 4 minus 4 get cancelled. Minus 12 minus 1 minus 1 into minus 1, it will be minus 1. So this becomes plus 1 for me. Finally, C2 equal to 1. So the asymptom y equal to m2 of x plus c2, right? So this becomes, what is my y? m2 equal to minus 2, right? Minus 2 into x plus 1. So I can write it as minus 2x, I will bring this side, 2x plus y minus 1 equal to 0. So now m3 equal to 2 I have. So for that what I have, C3 equal to minus of, direct line right now, by using this direct line, right, this becomes minus of 2m3 square minus 2m3 divided by 3m3 square minus, sorry, plus 2m3 square, plus 2m3 minus 4. Is it clear? 3 plus 4. So this becomes C3 equal to minus of, replace the m3 value, 2 into 2 square minus 2 into 2 divided by minus 3 into 2 square plus 2 into 2 plus 4. So this becomes C3 equal to minus of 8. 2 into 4 is 8 minus 4 divided by, here it will be minus 12 plus 4 plus 4. So this becomes 4 divided by minus of 4 divided by, look at it, minus 4. The solution is 1. My C3 value is 1. For m3 equal to 2, I got C3 equal to 1. My asymptom y equal to m3 of x plus c3, that's equal to y3 equal to y equal to m3 is 2, right? 2 into x plus 1. So this becomes 2x plus 1 minus y equal to 0. I can be written, or else the standard form I can keep it 2x minus y plus 1 equal to 0. So all the asymptotes of the curve are y equal to x, one curve for me got it, second is curve y equal to, we already got second thing, that is y equal to, okay, you can write in a standard form 2x plus y minus 1 equal to 0. Now 2x minus y plus 1 equal to 0.